Hi everyone, welcome back to my video. So let's go ahead and solve some algebra problems from some math competition. So let's look at this problem 21. Given A is the sum of all positive factors of 1024, B is the product of all positive factors of 1024, then we have these multiple choice answers and we have to pick the right relation. So let's start off by writing 1024 is equal to 2 to the 10th power, and then the factors of 1024 are going to be 2 to the 0 power, to the 1 power, to the 2 power, all the way up to 2 to the 10 power. So in other words, there's 11 factors we're looking at. So A is equal to 2 to the 0 plus 2 to the 1 all the way up to 2 to the 10th power. So this is going to be kind of like a geometric series, right? So A1 equals 1, which is 2 to the 0 power, r equals 2, because we're multiplying each term by 2, and then n is equal to 11, you plug this in, and then we get the sum is equal to 2 to the 11th power minus 1. B is equal to 2 to the 0 power times 2 to the 1 power times 2 to the 2 power, all the way up to 2 to the 10th power. So I can write this as, well, we want to find the sum here, right? Because we can write this as 2 to the power of 0 plus 1 all the way up to 10. So 1 plus 2 plus 3 all the way up to 10 is an arithmetic sum, and its sum is equal to 55. So B is equal to 2 to the 55th power. A is equal to 2 to the 11th power minus 1. So let's try to find a relation between A and B. So if I do A plus 1, cancel these 1's, and I get 2 to the 11th power. If I raise 2 to the 11th power to the 5th power, which is A plus 1 to the 5th power, we get 2 to the 55th power, which is equal to B. In other words, A plus 1 raised to the 5th power is equal to B. So the correct answer is B for this problem. Problem 25, given 4 distinct straight lines that go through the origin of a coordinate system, these lines intersect the parabola y equals x squared minus 2 at 8 points, and we want to find the product of the x coordinates of these 8 points. So the first thing we want to write down is that a straight line that passes through the origin of a coordinate system has the equation y equals m times x, where m is a parameter. So the equations of the 4 lines are going to be what? Y equals m1 times x, y equals m2 times x, y equals m3 times x, and y is equal to m4 times x. So if x1 and x2 are solutions to a quadratic equation, we can write this relation here, x squared minus the sum of the solutions times x plus the product of the solutions is equal to 0, and that's what we're going to use to solve this problem. So the intersection of y equals m1 times x and y equals x squared minus 2, we can solve this as m1x equals x squared minus 2, and then we can rearrange terms to get this. So the product of the x coordinate solutions, x1, x2 is x1 times x2 equals minus 2, right? The intersection of y equals m2 times x and y equals y, and y is equal to x squared minus 2. We solve this equation, rearrange terms, and then we get the same deal, right? So the product of the x coordinate solutions, x3 and x4, is x3 times x4 equals minus 2. We can repeat the process for the intersection of y equals m3x and y is equal to x squared minus 2, and then again for y equals m4x and y is equal to x squared minus 2. So then we get x5 times x6 equals minus 2, x7 times x8 equals minus 2. So the product of the x coordinates of these 8 points is just going to be the product of x1, x2 all the way up to x8. Right, and then we know x1 times x2 is minus 2, x3 times x4 is minus 2, all the way up to x7 times x8 is also minus 2, so we get minus 2 times minus 2 times minus 2 times minus 2, which is equal to 16. Okay, so this is the last problem I'm going to solve tonight, problem 28. So we're given a sequence an with a1 equals 49. To find an plus 1 for n greater than or equal to 1, you add 1 to the digit sum of an and square the result. So in other words, a2 is equal to 4 plus 9 plus 1 squared, which is equal to 196, right? Because a1 is 49, so the digit sum of a1 is going to be 4 plus 9, 13, and then you add 1, 14, and then you square it to get 196. So find a 2019. So this was a kind of a fun problem to solve. So you just want to find a pattern, and you can kind of calculate, the first several terms, and I won't, bore you with these calculations. You can just look them over. But when you get to a5, which is equal to 25, when you do a6, you get 2 plus 5 plus 1 squared, which is 8 squared, which is equal to 64. a7 equals 6 plus 4 plus 1 squared, which is equal to 121. And then a8 is equal to 5 squared, which is equal to 25. So starting with a5, we see this kind of, we see that the values kind of cycle, right? So of period 3. So in other words, a5 equals a8, a6 is going to be equal to a9, and a7 is equal to a10. And you can, compute those if you want, but I'll just write the sequence cycles for n is greater than or equal to 5 and period n is equal to 3. So we get this kind of general relation here. a5 plus 3n equals 25, a6 plus 3n equals 64, and a7 plus 3n is equal to 121. So if we want a 2019, we're going to solve these equations, set them equal to 2019, and see if we can find an integer solution. So the first one, 5 plus 3n equals 2019, means 3n is equal to 2014. That has no integer solution. We'll try the second one. 6 plus 3n equals 2019. 3n is equal to 2013, and n is equal to 671. So this works, and that's what we're going to choose. So a 2019 is equal to a 6 plus 3n. 6 plus 3n is equal to 8 squared, which is equal to 64. So a 2019 equals 64. So that's all I have for you tonight. I hope you enjoyed watching these videos, and I look forward to seeing you during my next tutorials. Alright, everyone, have a good night.